Welcome back to the Foundry by Forge College. Let's jump right in. We're continuing our track on deploying on Solana, right in the middle of our deployment strategies and scripts module. And today we really need to talk about a transformation. You know that one drawer in your kitchen? Yeah, the junk drawer. It's stuffed with rubber bands, dead batteries, maybe half a pair of scissors. Well, let's be honest, a lot of deployment scripts look exactly like that. I mean, they might technically work, but trying to find what you need or change a single line? Absolute nightmare. So in today's explainer, which is part of our fundamentals of deployment scripts, we're going to fix that. We're turning that junk drawer of code into a masterfully organized engineering blueprint. Today, it's all about structuring deployment scripts.
Here's the 6-stage blueprint we'll be following today. First up, from messy to modular. Second, the 4 core modules. Third, monolith versus modular scripts. Fourth, inside the code scaffold. Fifth, verification and safe automation. And finally, preparing for CI and CD. We're going to move fast, but by the end of this, you'll know exactly how to prep your scripts for heavy-duty automation.
All right, section 1, from messy to modular.
So right now, if you're running a massive linear script from top to bottom, what you essentially have is a giant house of cards just waiting for a slight breeze to knock the whole thing over. To fix that, we have to look at our timeline. In our previous lesson, Introduction to Deployment Scripting, we moved from manual one-off jobs to basic idempotence. Remember? We added simple safety checks so we wouldn't accidentally do things like mint the exact same token twice. But today, our goal is the final step on this timeline, evolving those basic scripts into fully automation-ready CI/CD pipelines. We are literally laying down the track so the train can drive itself.
Moving right along to section 2, the 4 core modules.
To keep that house of cards from collapsing, we need some serious structural buckets. I like to call this the rule of 4. These are 4 distinct responsibilities that keep your cognitive load super light and make your scripts infinitely scalable. Configuration, tasks, orchestrator, and verifiers. Separating these specific concerns, that is the magic trick that stops your code from turning back into a junk drawer over time. Let's break down the heavy hitters, starting with the orchestrator. You can think of the orchestrator as the site foreman on a construction project. The foreman isn't actually picking up a hammer, right? They aren't doing the heavy lifting. Instead, they're reading the blueprint, directing the tasks, and managing all the tricky stuff like retries and concurrency based on your configured data. They just tell everyone else what to do and exactly when to do it. Next up, the verifier. So if the orchestrator is the foreman, the verifier is your absolutely ruthless QA inspector. They execute really fast, deterministic checks to confirm that a task was actually completed. This heavily reinforces that idempotence principle we covered before. They check the state of the network before and after the work is done to make absolutely sure we aren't duplicating our efforts. Now take a look at this sequential flow of data. Step 1, load the config. Step 2, the orchestrator reads that config. Step 3, it triggers the tasks. And step 4, verifiers check the state. The beauty here is that we pass a single immutable config object straight down the chain. Because that config doesn't magically change halfway through the process, your tasks remain perfectly 100% predictable. Which brings us to section 3, monolith versus modular scripts. Okay, time for a little technical comparison. And yeah, we're going to poke a bit of fun at the old way of doing things. But before we get into the breakdown, ask yourself this. Why is a modular architecture actually superior to a monolithic script for CI/CD? I mean, it kind of seems like way more work up front to write all these separate files, right? Why not just write one big chunky script and hit run? Well, the difference is literally night and day. Over on the left, you've got the linear monolith, one massive file. Your configuration reads are scattered all over the place, and the errors? Oh boy. You've got these global try-catches that just swallow errors whole and leave you totally guessing. It's a huge coding faux pas and it completely breaks automation. But look on the right at the modular approach. Separated modules, a single injected loader for your config, an orchestrator that smartly handles retries, and isolated mocks for your testing. It's a total game changer for reliability.
All right, section 4, inside the code scaffold.
Let's actually break down the code structure now. And as a quick side note, building these types of rock-solid scaffolds is a core part of the foundational engineering programs we run at Forge College. So first up is the entry point. The pseudocode here is simple but incredibly powerful. Load your normalize config, hash it for the logs, and pass it right to the orchestrator. Generating a config hash at the very start? That is a total pro move. It makes logging so easy to correlate later on. If something breaks in CI, you know the exact configuration values that were used for that specific run, no guessing.
Next is the task module itself. Now listen closely because this is absolutely crucial. Do not throw exceptions for expected failures. Actually, let me repeat that because it's that important. Don't use exceptions for things you know might happen. We save exceptions for truly exceptional, catastrophic things. For standard, recoverable hiccups, like, say, an account already existing, just return a pure status object instead. Here is a perfect example of what that status object looks like. Status skipped. Reason already deployed. Returning a structured object like this completely empowers your orchestrator. It can look at it and deterministically say, okay, cool, this step is already done, let's just move on to the next task, instead of the entire script crashing and burning. And that takes us right into section 5, verification and safe automation. This right here is what lets your automation run totally unattended, without waking you up with a blaring server alert at 2 a.m. Let's look at the 2 places we put our verifiers. The pre-task verifier is a lightning-fast check to see if we should skip or run a task. It completely prevents redundant work. On the flip side, the post-task verifier comes immediately after the task runs, just to confirm the side effect actually matches our expected state. Think of it like this. The pre-task saves you time, but the post-task guarantees the job actually succeeded. All of this ties beautifully into your error handling and structured JSON logging. Transient errors, like a temporary network timeout, those get retry strategies. Permanent errors, those halt the flow and exit with a non-zero status right away. And through the whole process, context objects are capturing your task names and inputs. These cross-cutting concerns give your post-mortem automation the exact context it needs to take conditional actions if things go sideways. Finally, section 6, preparing for CI and CD. Everything we've drafted up to this point perfectly sets the stage for continuous integration and delivery. Because our architecture is highly modular and our orchestrator is strictly data-driven, the benefits are just massive. You get data-driven task lists, declarative pipelines, partial flow reruns, and even parallel execution. Your CI system doesn't even need to know how the code works. It just passes the orchestrator a trimmed list of phases to execute on the fly. It is beautiful, efficient automation. As we wrap this up, I want to leave you with a quick challenge. Look at your own code. Which 3 tasks in your current deployment scripts can you extract into standalone modules today? Seriously, pull up your messiest script. Find a build step, a config step, or a verification step and pull it out. Try applying this blueprint right now. Our next explainer is going to cover automation for deployments, where we'll take this brand new CI-friendly scaffold and actually wire it up into real pipelines. To discover more Web3 engineering content and master topics exactly like this one, definitely visit forge.college. Thanks so much for hanging out with me on this explainer today. Keep building, and I will see you next time.